Hi everyone, welcome to Skilled Inspirational Academy. This is free CCNA day 16 class. So today we got 4 topics to discuss. Let me start with routing first. So we'll take a look about what is route and what is the different types of routes that's possible in Cisco iOS. So let's get started. Let me open up my whiteboard. So here in an example, I'll take a very small network here. Let's consider this as a switch and a router. I got a switch and router, and now I have PCs connected to it. And I got one more WAN connection. I got LAN 2, and this is LAN 1. All these PCs are connected to the network. Pretty simple design. So this is LAN 1 and LAN 2. And I've been assigning 10 network for LAN 1 and 20 network for LAN 2. So this PC, right? If it wants to send a packet back to PC2, these are all connected to the switches. We all know about that, how the switch, forward packets based on the frame. When it looks the frames of the source and destination, it forwards the frames between the endpoints. But whereas if two different LANs are connected, right, here comes a routing. Because for this network, for this LAN users, they don't know how to reach 20 network. So we have seen in the life of a packet that if the network is not in the same, if the destination is not in the same network, it has to send this packet back to the default gateway. We all aware of this, right? So what is the very first packet it's going to send? It's going to send an ARP packet, ARP request. Because this PC is not aware of the destination. We all know about that. And we discussed about once this packet goes to the default gateway, it will check inside the routing table. So today the objective is what is routing table and how the routing table, how the router is aware of all the routes that's connected, and what is the difference between static route, what is directly connected network, what is local routes. It's a deep dive about the routes. And the routing, the core basics of routing is you can do 2 types of routing. One is manual routing, and other one is a dynamic routing. So manual routing is something you are educating the router where your destination is. You have to write you have to write a command, a specific command that enables a route. This needs more efforts. Something you have to go type in how it has to, through which interface it has to go, and what is the network I need to reach. So you have to feed all this informations to the router. That is manual routing. So the manual routing is further classified into 2 types. One is static route, and other one is a default route. So this is a basic high-level overview of the classifications of routes So we'll go in deep about the static route now. So let me delete this. So let me take one more topology, simple topology, to go with static route. The same way I got a switch and I got a router, and this is a WAN connection again. This is switch 2. This is LAN 1 and this is LAN 2. So you got PCs connected to it, and the PCs are assigned to LAN 2. And this is 20 network, and this is 30 network. So what is static route first? So before that, I have to give let's go from step by step. For the routers, for the directly connected devices, these are all the directly connected devices. You no need to, you no need to educate the router about the directly connected devices because it's directly connected and it is aware of. So in this case, if I got a LAN, this is LAN 1, LAN 2, and this is LAN 3. This router is aware of this network, right? This particular network and this network. Let's take this as a network 1 and this is a network 2. And I'm going to assign a range. So let me make it as 192.168.0.0/24. And this network is 20 network. Since for these two networks, we know you no need to specify any routes to reach the destination because this is directly connected. It's aware of. But whereas in this example, I got one more LAN 3, and you got a switch connected, and you got a LAN 3 here. And this LAN is something 50.0.0.0/8. This router is not aware of 50 network. So if this is your requirement, and if you want this users, LAN 1 users, to connect to LAN 3, I need to manually specify the route, a static route to 50 network. So here comes the static route. Unless it is directly connected, you don't need to specify any routes to reach the destination. It is aware of. Whereas for the LAN 3, from this perspective, for this topology, I have to write a static route to reach 50 network. So this is the ideology of routes. Here comes why I need a route. And this router is aware of this 20 network and 192 network, whereas it is not aware of this network, not aware of this 30 network. But the router 2 here, this is aware of 30 network, but whereas router 1 is not aware of 30 network. What I have to do now? So I have to write again a static route for 30 network. From the R1 perspective, if I want to reach the 30 network, I have to write a static route. If not, say for example, let me explain the packet flows. If this is a source IP, 20.0.0.2 is my source IP here, and the destination IP is 30.0.0.2. Example, this is assigned to this PC, 30.0.0.2. It goes inside, since this is not in the same network, it's going to send this back to the default gateway. So my default gateway would be on the same network, 20 network. So for example, 20 network is here, right? So I got a gateway, something like 20.0.0.1. It forwards this packet to this gateway, 20.0.0.1. And it checks the routing table, right? That's the first process when it is not in the same network, it is not directly connected, what it going to do, it going to check the routing table. And if there is no routes configured, it's going to drop this packet because this is not aware of this. So I'll give you a very simple example. This is something you have to feed the brain of the router manually to learn the routes. That is static routes. For directly connected devices, it is aware of. But if it wants to reach a different destination that's not directly connected, that is 2 or 3 hops away, or maybe the destination is not directly connected. If that is the case, these two criteria, if it is not then the next stop, or maybe it's a 4 or 5 hops away, it's entirely a different network and it is not directly connected to the router, you have to manually configure the static route. Only then it can reach the destination. This is the ideology of route and why we need a route. And we'll go further. So say, for example, if I'll take the same topology. Let me redraw this. This is R1 and this is R2. And I got a switch. This is LAN 1. This is LAN 2. And this is 20 network. And this is 30 network. And I got a PC here. So I got one more network here. Let me make it as a R3. And it is 30.0.0.0/16. /16. Say, for example, this router here, it's directly connected to 30 network, 30.0.0.0/16 and 30.0.0.0/8. So the PC with IP address 30.0.0.2 and the subnet mask of 255.0.0.0. So this is subnet mask value it's been assigned, and the default gateway would be 30.0.0.1. That's configured here, 30.0.0.1. This is the gateway for this network. LAN 2. And this is 30.0.0/16. This is important. So I got different network. Even though it looks like a 30 network, I got different subnet mask value. So if it is a different subnet mask, both are in a different network. So if this is the case, and if this PC 20.0.0.1, sorry, 20.0.0.2 and the default gateway is 20.0.0.1. This is my source IP address here. And my destination IP address is 30.0.0.2. So what happens here? See, 30 network is not in my network. This is directly connected to this router. So this is going to send this to the default gateway 20.0.0.1, and the router looks inside the routing table. So it got an entry of 30.0.0.0/8 because that is directly connected. So since the destination IP is 30.0.0.2, this will be forwarded back to R2. So now it's going to check the routing table. So what all the routes I got here? This is, I got 30.0.0.0/8 and 30.0.0.0/16. So I got, two networks here with different subnet mask value. So based on the subnet mask value, this is 255.0.0.0 and this is 255.255/16, right? .0.0. It's going to send a packet back to this 30.0.0.2, being this PC has been assigned with IP address 30.0.0.2 and the subnet mask is 255.0.0.0. The subnet mask is very important here. So based on the subnet mask, it classifies, even though it looks like a 13 network, but since it's a different subnet mask, so different network. So you should understand about this. This is a use case. You may have to, configure your appliances, and you have a requirement to configure two networks with the same network range, something like 30 network 30.0.0.0/8 and /24. So this is how the router forward the packets based on the subnet mask, and this is how the route lookup happens in the router. So let's do a lab now. So in this example, I'll take, first let's explain the directly connected devices. So I got two PCs. Connected to the router. So we all know the router ports are not auto negotiated port. We have to go manually bounce the ports. So the very first command to check the interface status, show IP interface brief. So it shows the list of interfaces in the router. So now GI0/0/0 is connected to the PC1. So in the same way, I'm going to bounce the second port, GI0/0/1. No shutdown command. That's it, done. And how to check that? Again, if I give show IP interface brief, I have to see both my protocol and status should be up. Status is something your L1 connection, and protocol is something the same protocol is being negotiated. So let me go inside the GI0/0. And I'm going to give an IP address 10.0.0.1 and default subnet mask value. That's it, done. So I'll go inside GI0/0/1, IP address 20.0.0.1, and the default subnet mask value, class A. So I got 10 and 20 network configured. This is the IP address gateway. That's it. I'm done with the configuration. I'm going to check this back again. Okay, I have assigned the subnet mask value. Everything looks good. So let's go inside the PC and configure the IP address for the PCs. Going to give a static IP address here. 10.0.0.2 default subnet mask and 10.0.0.1. That's it. And I'm going to assign an IP address here, 20.0.0.2 default subnet mask value, and 20.0.0.1 is my gateway. So I'm going to verify. Yeah, I have assigned the IP address for PC A and PC B. So now let me check the connection for the gateway. It's 10.0.0.1. I can ping. What is this? 20.0.0.2. Let me try if I can reach 20.0.0.2. I can't reach, right? Okay, so What is the command I should use to check the routes? Show IP route. So what it says, 10 network is directly connected, right? 10 network is directly connected on this port, GA0/0/0/8. And if I see 20,000, it's connected on GI0/0/1/8. So this is all directly connected. I haven't configured anything. All I did is just configured the gateways to the interfaces and connected two PCs, right? This is connecting two different LANs, but still I have a connection because these two devices are directly connected. So it learned about this network by itself, just with the gateways that's configured. We haven't done any any routing information. We haven't done any kind of routing configuration in the switch so far, but still it learned about 10 and 20 network because this is all directly connected. For directly connected devices, you don't need routes, and you have to check the output here. See, this is 20.0.0.1/32 exact match. So what is the representation of the subnet mask here? 20.0.0.1 and 255.255.255.255, the exact match. This IP 20.0.0.1 is the only IP address in this range, the directly connected /32. If you did see this 10.0.0.0.8, it means 255.0.0.0, all the 10 network. Your 10.0.0.2 until your 10.0.0.255, sorry, 10.255.255.255, 2 to the power of 24 minus 2. It learned about all this network /8. But whereas /32, it reaches only for that specific destination. You should understand about the route entries inside the router. So if a PC wants to reach the gateway, right, it's going to check the routing table and it's going to match only this, because this is it always prefers the longest prefix match. If a packet from PC 0 goes to 20.0.0.1, it's going to use this entry to reach the packet because that's directly connected and this is the longest prefix match. Even though I got 20 network here, 20.0.0.0/8 and 32, if I want to reach 20.0.0.1, and this is the exact, match, prefix match, it's going to send the packet to. So this is longest prefix match. So let's now do a topology with different LANs and we'll create a static route. I don't want to delete this. I'll add one more router. I'm going to delete all these PCs. So now we'll connect switches. And for testing, it'll connect two PCs in every LAN. I have a connection back to the routers, and I got one more connection going to my LAN. Okay, so interface GI0/0/0, no shutdown. And in the other end, GI0/0/0, no shutdown. And all my L1 connections are up and running. And the interface connected to the switch was GI0/0/1, no shutdown. To differentiate, I'll make this host as LAN2. Let me change the host name as LAN2. So let me make this as a LAN1. So it's done. So next, assigning an IP address to the interfaces. Interface GI0/0/1. IP address 10.0.0.1.255.0.0.0. Okay, we have assigned this to this interface. Let me check the configuration. So it's been already there for G. So it's overlapping, right? Because since I have assigned this already to GI0/0/0, I cannot assign this because it says it's overlaps the IP address. It's been assigned already to GI0/0/0. So I'm going to pick other network here. So let me give GI0/0/1 as 20.0.0.1. Yeah. I give show IP interface brief. I'm going to see 10 and 20 network, both my L1 and the protocol status, both are up and running. I'm good. So I'm moving back to the second network. So GI0/0 is 10 network. And this is 20 network. So what should I configure on the other end here? In the same range, right? Because this is a point-to-point connection. If I assign 10.0.0/1 to this interface, so I'm going to assign same IP address in the same range with same subnet mask. This is a point-to-point connection. So in the router 2, interface GI0/0/0, IP address 10.0.0.2, and the default subnet mask value is 255.0.0.0. Done. And here, let me take 30 network here. /8 for this interface. This is for this interface. So go inside the interface, GI0/0/1, IP address 30.0.0.1, and default subnet mask value 255.0.0.0. I'm going to check. So IP interface brief. Okay, 10 GI0/0/1 is assigned to 30 network. And GI0/0/0, a point-to-point connection back to the R1 is configured for 10.0.0.2 here. Let's do a testing now. Let me assign an IP address in the 20 range. .5, and default subnet mask is 255.0.0.0, and the gateway is 20.0.0.1. Done. Let me check a connection. If I can ping 20.0.0.1, I can ping. Let's try if I can ping 10.0.0.1. What is the expectation? Yeah, it should reach because it's directly connected. But if I try to reach ping 10.0.0.2, it should not work, right? Because that is not directly connected. Request timed out. I don't know if the traceroute command works. Okay. So what happens here? So it reaches the gateway, but after that, it cannot reach the destination. So traceroute is very helpful command to see every single hop it takes until it reaches the destination. For the troubleshooting standpoint, traceroute is very useful command. The request timed out because within the given time, it cannot reach the destination. And if I do a traceroute, sorry, tracer T is a command to 10.0.0.1. So what it says, it reaches 10.0.0.1, just one hop away, because that is directly connected. So if I want to reach this 10 network from this router, what should I do now? I want to do a static route. How do I do that? IP route. What is the network? 10.0.0.0, 255.0.0.0, default subnet mask value. And if you give a question mark, no, you got two options. One is your next hop. So what is the next hop here? So from this router for 10.0.0.1, my next hop is 10.0.0.2 because that is the only directly connected device. It's saying, hey, I don't know where is 10.0.0.2. Just I'll forward this packet to you. Just take care about that. Something like that. So I'm going to hand over this to you, and it's your responsibility to reach the destination. So how do I do that? So IP route followed by the destination network. Here is 10,000 and the subnet mask value, right? If I give a question mark here, you will see that destination prefix mask, that's your 255.0.0.0. And your next hop or your interface, the living interface, where my egress traffic goes now. This is my living interface now, right? GI0/0/0 is the egress interface for 10 network from R1. So it's going to send this packet back to this interface, and from this interface, it's going to reach 10,000 network on the other end, R2. So I can give either the next hop. My next hop is 10,002. So here I'm going to give the next hop here, 10,000.0.0.2. And metric, this is very important. See, you for every route, you have a metric values you can define the distance. Say for example, if you got two routes, if I got one more route, something like 10,000.0.0, if I want to reach the same network with a different subnet mask value, and if this route flushed out, if there is no destination that's responding for this network, and I have to look the routing table for the 10 network with the different subnet mask, you can change the metric values. The least is most preferred. Example, if I got two routes, 10,000.0.0, and the subnet mask is 255.0.0.0, and I got, two ways to reach 10 network. This is the first path, and this is my second path. If I make a matrices something like 10 and other matrices 20 for the same network, it's going to choose my least value. Least is most preferred. I mean, for today, this is a first class for routing, so we don't want to look about that. Let's just an overview. Let's jump into the configuration. So now for 10 network, on the other end, the next hop is 10,000.0.0.2. And that's it. I'm going to press enter here. And if you give show IP route, so what is the network that's configured? See 10.0.0.0 and /8. And if I initiate a packet from this PC2, can I reach? No. So what happens now? See, here in this router, I know about 10.0.0.0/8. But whereas for this router, this is not aware of this network, right? This LAN is not aware for this router 2, because this is directly connected to this device. So what happens here? Now we initiated a traffic. The traffic is going from here 10.0.0.2, and the destination is 10.0.0.2 here. Sorry, this is 10.0.0. One minute, let me quickly check the IP address here. So 20.0.0.5, sorry. So this is the IP address configured here, 20.0.0.5. So what happens? This packet is the source, from the source 20.0.0.5, and it tries to reach 10.0.0.0.2. And we made a static route, right, to learn about this network. Since it's directly connected, it's not needed. But when the return route that comes back again, how this router is aware of 20 network? If I go and check inside the routing table of R2, I do not see the 20 network, right? If you give show IP route command here, I know only about 10 and 30 network, not about the 20 network. So what should I do now? I want to make this router to learn about where is 20 network. Since it's not in my local LAN, what should I do now? The same process from here. I'm going to write a route, IP route. My destination is 20.0.0.0, and the subnet mask is 255.0.0.0. And what is the next hop address here? That is 10.0.0.1, right? That's directly connected to this router. So I'm going to give 10.0.0.1. Let me go back and check the routing table again. So it says if this is yes, static, S stands for static, we should know about this terminologies. L stands for local, S stands for static, or for RIP. And so in the later classes, we'll discuss about all that. But I want to, show you this. If every alphabet has its own meaning. S stands for static, and here for 20 network we made a static route, and it's showing here with the subnet mask value. And so this is the administrative distance. The default value for static route is 1, and it's going via 10.0.0.1. So let's try now from here. If I can reach 10.20.0.0.0.1, I can reach. Can I reach 20.0.0.5? I can reach. Can we try from the PC here? This is my 20.0.0.5. And now what happened for 10.0.0.2, we got a request timed out now. And if I ping, I get a reply back. Why? Now I got a return route. This router is aware of this 20 network. Since it's not directly connected, I'm going to forward this packet back to this router 1 on 10 network. And once it reaches this, it will check inside the routing table. And since this is directly connected, it's going to forward this packet to 20.0.0.0. And in the real use case, if you want to check a route for a specific destination, the very best command is always give show IP route followed by the IP address. I don't know, it works in the packet tracer. Can you see this? It says it goes via 10.0.0.1. So how I learned about this? Known via static, and the distance is 1. And the route descriptor blocks is 10. Through this 10 network, I am reaching 20 network. That's the meaning of this route descriptor. I'll show you. We have no network something like 60.0.0.1. So what it says, network not in the table. What table? Inside the routing table, there is no network. There is no route entry for 60 network. That's the meaning of this. This network is not in the routing table. But when I give show IP route 30.0.0.1, can you see this? The exact match it says. Where is 30.0.0.32? This one, local route. L stands for local. That's local to this device. What is the exact prefix length? 30.0.0.1/32. It's going to prefer this. It's directly connected, and it's going to send this packet out on GI 0/0/1. So if you have routes for 2 for the same destination, right? For the same destination, you got two routes, but it's always going to prefer the highest prefix length. This is important. It's always going to prefer the highest prefix length. So now let's try to reach the 30 network from here. What should I check first? Do I know about 30 network? No. Let's do a testing very quickly. Go to desktop and give 30.0.0.5 and my gateway is 30.0.0.1. Let me go check. This is 30.0.0.1. Let me try to ping 30.0.0.1. I can't reach. But from this PC, let's try 30.0.0.1. Destination host unreachable. So what should I do now? Inside the routing table, I do not have route for 30 network. Can you see this? I have route for only for 10 and 20 network. So I have to go manually add a static route for 30 network. In the same way, what is this network? This network is 20 network, right? This is 20 network. So do I know about the 30 network from the auto perspective? 20 network is, I know about, I'm going to send this packet to 20 network via 10.0.0.1. So I have to make a route here for 30 network. IP route 30.0.0.0 and default subnet mask is 255.0.0.0 and my next hop would be, the directly connected, that's 10.0.0.2. So if I go back and check the routing table, I know about 30 network and it is a static route. But my next hop is I'm going to 30 network via 10.0.0.2 because that's not directly connected. I don't know about that. So I'm going to forward this packet to 10.0.0.2. And since from the R2 perspective, 30 network is directly connected, it's going to forward this packet back. Now let's test the connection. I can reach 30.0.0.1, this gateway that's not directly connected. So what is the IP address of this PC? It's 30.0.0.5. Let's try ping 30.0.0.5. I can't reach. If I do a trace to 30.0.0.5, you will get to know every hop it takes. Can you see this? The first packet, it goes to the gateway, and then it goes to 10 network, and then it reaches the 30 network. Right? First, the packet goes to the gateway, 20.0.0.1. The gateway, and then the next hop. Next hop is here. First, 20.0.0.1. So it checks the routing table. And I know about this network, this is directly connected, and it's going to send this packet back to 10.0.0.2. Once it reaches here, it's going to check its routing table again. And this is a directly connected, right? This 30 network. So it's going to send this back to 30 network. This is the packet flow from source to destination when it wants to reach a different network from the source PC. And finally, we'll look at what is default route. I'll give an overview about default route. Let's do a small use case, pretty simple. So default route is something you mostly use this, the ISP. Say, for example, this is your internet router where your internet connection, your WAN connection goes. So how do I reach google.com, yahoo.com, facebook.com, your Office 365, and everything that's hosted in the internet, right? I cannot write a route for every single destination. There's tons of routes, right? I cannot do that. So the ideology of static route is it says all zeros, all network, all subnet mask, and my default gateway is the gateway of the ISP. It's pretty simple like that. So here, let's give show run command to check the list of routes I got. I got routes for 10 network and I got route for 30 network, right? I'm going to remove this. So now this PC cannot reach 30 network, right? Because I've removed the route for 30 network. Let me ping. Destination host unreachable. So I don't know where is 30 network, but what I'm going to do here, IP route all zeros, any network, any subnet mask, all zeros. And what is the next hop? It's 10.0.0.2. If I give show IP route, so for 30 network, what happens here? From this PC, I want to get to 30 network. So it's going to send this to the gateway. So my gateway here is for 20 network, that is 20.0.0.1. So once it reaches the gateway, it's going to check the routing table. So here it exactly looks for every single match. So is there 30 network? No, 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 no. But whereas in the last static route, can you see this gateway of lost reset is something? If your route is not, your destination is not matching with any of these entries, it's going to forward this packet to this gateway, since the default route points to 10.0.0.2. It is not matching anything here. So it is something, I don't know anything. Whatever it comes, if it is not in my routing table, it's going to send this to 10.0.0.2. Here is a question. If it want to reach 20.0.0.1, it's always going to prefer this local route, not the static route. Since I do not have an entry for 30 network, it's going to send this packet back to this entry, the default route. Let's try if I can reach the destination. So I'm going to ping 30.0.0.5. Can you see this? I can reach this. Let me go and remove a default route and see if I can reach 30 network. Okay, if I go and check inside my routing table, there is nothing. I have no information about 30 network here, no information at all. So if I try to ping 30.0.0.5 destination host unreachable, because this router is not aware of 30 network. That is a use of default route. As I told, the use case is something you have, at different LANs. It might be running on 30.0.0.0, and this is on 40.0.0.0, and you're connected to your ISP, internet service provider, and the Google, Yahoo, and your Office 365, anything that's hosted in the internet. I cannot make a route for every single destination, every single network. There's tons of application hosted. So instead, what I'm going to do, I'm just going to a simple command, IP route. This covers all networks, all subnet mask value. And my next hop is what? Example, this is 198.168.1.1, and this is 192.168.1.2. So my next hop is 192.168.1.2. That's it. Now it's the responsibility of the internet service provider to route this packet back to the destination. This is the use of default routes. If there is no default route, you have to write a route for every single destination in the internet. But with the default route, all you have to do is you have to forward all the packets that's unknown to this router. You will forwarding this packet back to the ISP, the next hop. That's it, your job is done. I hope today we have gone through what is static route, what is default route, and we have seen how the router checks the routing table, and what is longest prefix match, and what is administrative distance. And we have we have done multiple testing to remove the routes for a specific destination, and we tried with the default route, and we tried with static route, and we tried with directly connected networks. So I hope this is definitely helpful for you guys to understand how exactly the route lookup happens in the router, and what is the packet flow from source to destination. And we have seen list of commands to check for a specific destination. Show IP route followed by the destination network will give you, is it the route entries available in your routing table? If it is not, it says this network is not available in the network table. It is not aware of that. So hopefully we will connect tomorrow with the same topics, with many use cases. And really, I enjoyed this class today, and hopefully you guys enjoyed the class. And hopefully we'll meet tomorrow. Until then, have a great day. Bye. Bye, everyone. Thank you.